then I will just quickly introduce our today's speakers to you guys. And our first speaker is our partner from Italy, Luigi Santo Pietro. I'm really sorry if I pronounce it wrong. He is researcher at the Institute of Methodologies for Environmental Analysis of the National Research Council in Italy. And he has a degree in environmental engineering and also PhD in engineering for innovation and sustainable development. So very relevant for our today's webinar topic. He used to be a visiting scientist at the European Commission's Joint Research Center, where he had the chance to collaborate with different scientific support teams for the Covenant of Majors initiatives. And Luigi writes a lot of scientific publications on the topic. And currently he's conducting research on strategies and plans for climate change mitigation and adaptation, and more other topics that you can see on the screen. Very excited to have Luigi on our today's webinar. I will briefly introduce the second speaker, and then I will give my word to Luigi. Our second speaker is Marco Chavar. I'm not sure. I'm really sorry if I pronounce it wrong. I'm not fluent in Croatian. He is head of energy department at Northwest Croatia Regional Energy and Climate Energy. Energy. I'm very sorry. So he studied at the university in Denmark, and before that, he completed his undergraduate studies at the Faculty of Mechanical Engineering and Naval Architecture at the University of Zagreb. And he has joined Regea, also not sure, but we'll check with Marco a bit later, 18. So he has quite impressive experience of working there and applying to different European projects. And his main focus areas include PV systems, individual and district heating systems, energy efficiency in buildings, especially in terms of thermotechnical systems and automation systems. So we're also very excited to have Marco here, yeah, looking forward to his presentation. But first, we invite Luigi to proceed with his presentation. I will just stop sharing my screen and give Luigi an opportunity to continue.
Thank you, Anastasia. Good morning to everyone. I'm Luigi. I'm Santo Pietro. I'm a researcher at the National Research Council of Italy, and with my colleague Marco Chavar from Regea. In this webinar, we will show a decision support tool that was an output from an Interreg project, and will be useful to support decision about the renovation of building stock, specifically for the public building stock, but also for the private one. Let's see some key facts on energy efficiency and EU buildings. The goal set by the European Green Deal it's net zero GHG emission from EU cities by 2050. But 50% of energy consumed in EU is coming from buildings, and over 30% of the EU energy-related emission at EU level come from buildings. And going deeper, over 80% of energy use in EU from homes is related to heating, cooling, and hot water. But how is our building stock at EU level? 80-50% of EU building stock was built before 2000. And amongst those, 75% have a poor energy performance. What we can do? We can improve the saving energy. We can improve the energy efficiency of them with renovation actions. This to achieve the zero emission target set by 2050 with the European Green Deal. And the European Green Deal move on the pillar of the renovation and retrofitting existing building, either public and private. And however, at EU level, each EU country has a specific regulation on energy efficiency of building and energy efficiency target. There are some shared targets, and they are focused on tackling energy poverty, renovate public buildings as set by Energy Performance the Building Directive and Energy Efficiency Directive, and decarbonize the heating and cooling processes. And what are the benefits of renovating buildings in EU? Boost the energy efficiency of building means reduce CO2 emission and GHG emission, tackle energy poverty, but also promote and improve the economic recovery and job creation. And we have to remind that improve the energy efficiency of buildings means enhance citizen health and well-being by renovating the buildings. Investing in energy efficiency at the same time stimulate the local economies and improve the EU industrial sectors, improving and increasing the jobs at local level, but also stimulate the creation of new jobs, as example, green jobs. At the EU level and at local level, the renovation of buildings contribute to improve the whole supply chain related to energy efficiency, in adding new jobs and supporting local economies by, as example, producing all components related to energy efficiency, such as photovoltaic panels and so on. But if on a hand there are the benefits, on the other hand we have the barriers affecting the building renovation. There are three main barriers. The first one is, as Anastasia said, the financial barriers. No, we have the financial issues that's probably most relevant, and financial barriers are related to access to finance, to evaluate accurately payback expectation and investments horizons, but also price signals that are not very continuous. And also, barriers can be also institutional and administrative, such as regulatory and planning issues. Not all energy efficiency intervention can be possible, especially on the heritage, on our historical heritage buildings, but also institutional, structural, and related to the multi-stakeholder involvement and process. At least, but not at last, we have a barrier on the involvement of stakeholder and citizens in terms of awareness, increase of awareness related to the benefits and the possible outcomes deriving from the energy efficiency intervention. And this is probably the barrier most difficult among them to be addressed. So these are our challenge, and we have to work on the supply chain, the quality of workmanship, and improve and check where there are the technical failure that stop our process to energy efficiency. Let's move to the object of our workshop, that is the building. What are the components that affect the energy consumption of a building? So they can be external, like local and climatic condition, but also internal. They are the building envelope that is constituted of a roof, windows, and facade, but also lighting system and electrical devices that rule a important role in the energy consumption of a building, because all of us has a PC, fridge, and so on that work all day. And the total building energy consumption is built of consumption deriving from electrical devices, lighting system, and heating, ventilation, and air conditioning system. The heating, ventilation, and air conditioning system is the sum of the consumption from building envelope, the sum of consumption related to climatic condition, thermal comfort setting that constitute the heating and cooling needs. But we now move to a focus on these components. Considering the heating and cooling needs, we know that climatic condition rule a relevant role depends from the geographical location of each buildings and are different by different geographical location. Building envelope can have different issues related to the windows, to the roofs, to the facade, and as an important, and each of them has a important role in the sum of the total energy consumption. And at least each, as example, if we consider a building, each apartment, each people living in this building, ideal building, can ask for a different thermal comfort setting. So we have to set shared and just thermal comfort setting in order to reduce the energy consumption and have uh, the thermal comfort setting just to reduce the consumption. At the end, we have to improve these heating and ventilation and air conditioning system. We have to improve the lighting system to reduce the consumption, and also the electrical devices. And how we can do it? We can do it um, with the decision with a decision support tool that is the priority decision support tool. That's a open source user-friendly tool that can be transferred to energy planners, policymaker, and local administrators to support the design, implementation, and assessment of the energy efficiency action, energy efficiency intervention, considering that the public authorities have to manage their building stock according to the current Energy Performance Building Directive and the current Energy Efficiency Directive that have a specific focus, especially on public buildings, but also on the private ones. So I give and I pass the floor to my colleague Marco to continue our presentation with the decision support tool priority. Marco.
Yes, hello. Can you hear me?
Yeah.
Excellent. Then I will share my presentation. Thank you very much for the introduction and Luigi for the first part. I will follow up on the discussion and try to present you in about half an hour our work throughout 3 EU projects that ended up in developing a decision support tool. I will briefly explain it, but then in the second part of my presentation, I will split the screen so you will see the application and the slides and simply to be easier to follow. So what will I talk about today? Where just in brief, I will say something about Regea, just for you to get a context about who we are. Get the context, although Luigi explained it perfectly, about why the tool was developed, why we thought it is necessary. Then I will go into the decision support tool in brief to give you some basic information and history of the development. As I said, we developed it through 3 EU projects. So just to give you an insight of how we approach to the development of the tool. And lastly, I will dig up more into details with the shared screen to present you all the details and give you some more information. Lastly, as this is still work in progress, I will give one slide simply about the future work of what we are doing right now and what we plan to do. As I said, I will live showcase the tool all along. So just to say who is Regea or who are we? As it was said in the introduction, we are Northwest Croatia Regional Energy Climate Agency, developed in or established in 2008 through the Intelligent Europe program, when a lot of energy agencies were established across the Europe. And our main task is to support our founders, which are 4 counties in Croatia, city of Zagreb, Zagreb County, Karlovac County, and Krapina-Zagorje County. So let's say the northwest of Croatia. That's why we have this name. And what we basically do, we support them in dealing with energy-related topics. Across the sector, you will see some of the aspects. Currently, we are around 52 employees. And what is interesting, at least from our part, is that more than 90% of us are engineers, civil engineers, mechanical, electrical. So we are not a typical consultancy company, although that is our core business. We consult mostly our founders, and we develop and help them develop projects. Our projects are concerning energy retrofits, of course, the public buildings, not the private buildings, renewable energy sources, mostly PVs and batteries, district heating, EU projects. We have around 35 active at the moment, over 80 finalized, and we do a lot of analysis throughout this project. As you know, it is always important to say how much something costs and where you can find the funds and so on. And since recently, we added the climate aspect. We have a department with 15 people in climate area where we do climate mitigation, adaptation, and climate proofing of all the projects, especially big infrastructure projects. So what is our reference in this aspect? In the buildings, as I said, 4 founders, they have around 2,000 public buildings, so it's quite a lot, especially for the country like Croatia with around 4 million people. And our contribution to their work is that we first started with energy audits. So most of us are certified energy auditors, so we dig up into the topic by heart. We identify the potential projects for them. We do the preparation, monitoring, management of the various energy retrofits, all type of buildings. And we apply what we call the Green Deal design recommendations, or the book of standards for the designers, how they should approach in designing the buildings, which technologies they should use, how should they design, and so on. It's active for more than 10 years now, so we are constantly improving it, and it's like a book of all the standards and above standards measures that you should always follow. It is always in compliance with some EU fundings or national fundings and so on. We also do a lot of tender and contract documentation. We have our legal department, so we are juggling between traditional ESCO, public-private partnership, whatever the investor wants. And so far, we triggered around 750 million euros of investments in Croatia across the sector. Some of the biggest buildings in our area were partially or completely managed by us recently. The big stadium in Zagreb, the big sport hall, and so on. So we are really into the topic. So what is the context here? As you all know, I simply gave this slide to remind us all that total final energy consumption in EU is, I would say, if we have to select one sector, it is the buildings, which consumes around 35% of energy. Of course, it is divided to the residential and commercial and public services buildings, but it is still around 1/3 of the energy. And the first conclusion can be that all the buildings consume too much energy. Also, they emit a significant amount of CO2 emissions, and that is a kind of tricky situation when buildings are dependent on the fossil fuels. I do not have to elaborate that in details. You all know the geopolitical situation, price volatility, and so on. So why we encounter a situation like this? First, in buildings that we manage, we often see a lack of energy efficiency. That is not a surprise. All the EPBD, all the EU targets always says energy efficiency first. First, you have to lower your demand, then you can solve it and see how you can produce and meet the energy demand that you need. Then we often see an inadequate and time-wise incorrect maintenance, especially in the public sector, where usually owners, so public and regional, local and regional authorities, their only goal is to retrofit the buildings. Not many of them think about what will happen after you renovate. A building is like a car. You need to invest in the maintenance, otherwise in the 5, 10, 15 years, it will be completely worse situation than you imagine that it will be. And lastly, since we are talking about local and regional authorities, they deal with a lot of stuff. They deal with things which are outside of our sector, with the social topics, with the demographic topics, with a lot of different topics, and they often lack of knowledge, but also lack of time to properly manage their assets or buildings and to prepare the projects. It's not like they do not know how to do it if they could commit time. It's simply a combination of different factors that results in this area. And as I said, public buildings in many countries are a true reflection of above stated. We participated in a lot of EU projects. No matter which country, which region, it is always the same situation. Some aspects can be always better. So part of the solution for public sector is to introduce quick and easy digital tools to do various things, such as help manage building stock, identify, just to try to put this. Okay, now I went. I cannot somehow put this down, but it will go by time. So part of solution is the digital tool to help manage the building stock, to identify the most cost-optimal measures, either in the retrofits or the renewables, and to actually prepare short, mid, and long-term plans for the investments. So that is why we developed the decision support tool, which is, as said earlier, the online web-based application to do the, as I said, to do the, evaluation of cost effectiveness in terms of energy efficiency and renewable energy measures. This is just a brief description. I will go later into details, but basically it has three aspects. First, you input the data and evaluate the current state of the building. That is the first, I would say, aspect. Then you select the measures to identify the most beneficial renovation scenario, because you have many different options for each building, different types of insulation, different types of windows, different energy source for heating, and so on. And then you get the results and generate some reports. So that's in a nutshell what the decision support tool is. But on the other hand, there is one hidden purpose, which is to have the online registry of buildings, because as you will see, and I will mention it many times throughout this presentation, it is not 100% correct tool. It cannot be, but at least to have one place when you have the registry of buildings where you can find in one place with few clicks some basic informations, either consumption, either the overview of the documentation you have, or anything else. So simply for the public sector, which usually do not have any digital, I would say, archive or whatever, they usually save everything and keep everything in Excels or in some papers, just to have some digital tool that can help them monitor their buildings. This really bothers me, so I will try to put it somewhere. Yeah, okay. So that's why we developed the decision support tool, simply to give answers of what is the best value for money regarding these measures, either energy efficiency or renewables, and which is more often the case if investor has limited financial funds, where should this money go? Usually they do not have the money to retrofit the whole buildings. Maybe they have only for one or two measures or something like that. So with this tool, we aimed to give them the first impression, the first feeling of if it is more beneficial to renovate building envelopes such as windows, or to replace the heating source, or put the PV panels, and so on. So that's why we developed the tool, simply to promote these measures, because they are very necessary, and often in many regions, public buildings are considered good examples. So usually you start triggering the market by renovating the public buildings, and then later, when the sector is mature enough, prices are lower for residential sector. Then we developed it to help prioritize and trigger investments, as I said, either partial or deep energy retrofits, to give relatively transparent and objective evaluation of the investments. So what you get if you invest some money in terms of technical and financial parameters. And lastly, to enable seeing multiple pathways to achieve their targets. Sometimes they will achieve targets by only implementing PVs on all buildings, or by completely connecting all of the buildings to the district heating, and so on. Usually, it's not a single solution each time. So it is important to emphasize before I start more into details. Our tool is not a replacement for detailed feasibility and engineering studies. It never meant to be, although we all wanted it, but you simply need to understand that it is a soft replication of energy audits and certification process for the buildings that are missing some informations, or simply users do not have time to use engineering tools, or simply they do not know how to use them. They are not very easy to use. Back when we started in the priority, a lot of buildings didn't even have energy certificates. We had to go into site visits, assess, so you do not know without testing what is the thickness of the wall and so on. So this was just our soft replication of this whole process. Always in any digital tool, if you put the garbage in regarding the data, you will get the garbage out regarding the results. Same goes for the quality. So the more the better the input is, the better will be the results. And but what we can say about it is that it can give an easy overview for the authorities or other users where to dig more in the energy renovations process. As I said, and I will repeat many times, it is not 100% correct calculations, but at least you can conclude that renovating your walls or putting the insulation of walls will give you more benefits than simply replacing the windows. It can do the trick in that area. So what is the history of the development? 2 slides about that. We, as I said, and as it was mentioned before, we had 2 Interreg Mediterranean projects, Priority, and then the capitalization project called Priority Plus, where we developed the whole, among many other activities and among great partnership in 5 countries. So Spain, Portugal, Italy, Greece, and Croatia. We were, as Regea, in charge of developing the tool. So what we did and how this progress went is, first, we developed some basic calculation methodology with some input sheets, calculation of the measures, results, comparison. It's a standard procedure. I think that every EU project has it. But where we encountered the problem was that we missed a lot of parameters for a lot of buildings, because that's the biggest problem. So we approached that by defining the typical buildings. And if you go in every country, you will see that every methodology has typical buildings. It's because of that. So if you do not have some concrete info for this building, use the typical building, the typology, school, kindergarten, whatever, and assume some information. What we did here is that we gathered a lot of energy certificates in all 5 countries, and we developed some average values. If it is correct or if it is not correct, of course, it is not very correct, but at least it was some sort of scientific approach behind it. And then we modified the whole Excel. We prepared it to integrate on the online platform. We did some translations in 5 languages, and we moved it to the online platform. And once when we moved it, what we achieved, apart from being better in visualization and so on, we really could use programming skills of our programmers to get much more options in these calculations. So this was how it looked like back then in, I think, 2019. So for very different buildings, we evaluated a lot of different energy savings through different measures. You could select or deselect certain renovation measures. You could see which building has the most energy savings potential and so on. But you can agree that it is not very user-friendly, especially if you have to give this to the public authorities. They will hate you if you give them the Excel. So that's why we moved to the online platform. After we moved it to the online platform, we had another project which actually was finalized recently. It was the MeetMat project, where we basically took the tool as a good example and tried to transfer our knowledge to countries outside of the EU, such as Jordan, Algeria, and so on. And through that process, we added new countries. We added French as a standard language. We revamped the completely calculations and moved from the point where we calculated consumptions based of some formulas that were not correct, and we somehow, if I can say, try to replicate the standard algorithms for calculation of energy, primary energy, final consumption energy, and so on, according to the norms. And also we improved a lot of other things, but you will see that when I share the screen. This is the link to the decision support tool. It is free to use. You can register. It is very easy registration process, and you can use it for the unlimited number of buildings. And now I would try to just give me a second to put it in a different mode so that I can put it like this. Yeah, I hope that you will be able to see it. This is actually the tool. So what we did about this tool, why we like it so much. So it is, I would say, divided into several aspects. First, we have the dashboard of all the numbers, all the energy consumption, CO2 emissions, and share of renewables, and so on. Do not mind these numbers. There is a lot of testing buildings behind it. So probably it isn't. I'm the admin of the whole application, so I see all the buildings and all the numbers, and this is far too large number. Then we have the single feature building, where you can select, where you can input all the buildings. You can see the building, a lot of different information. I will go through all of this, but all the inputted buildings are here regarding the systems, regarding the building parts. What is the thickness of the insulation? What is the area of the insulation? What are the consumptions, and so on. We also have something called benchmarking, which is a separate area to compare your buildings. Now it is loading because there is a lot of buildings in it. But here you can select numerous buildings, I think up to 10, and then you can either look the total comparison of buildings, so in their current state and in their renovated state with applied measures, and you can actually compare the buildings between themselves. So you can see which building is the best regarding energy savings, primary energy savings, financial savings, and so on. Of course, then you can export the data. So for each building separately, or for the benchmarking option, you can download the report. I can show you maybe just how it looks like for one building. You will just give me a minute. So it basically, oh, now I cannot open it. Okay, I don't know why, but maybe later I will solve it and show it to you. It's because I'm now in this shared screen. And we also, what we are very proud of is that we have a list of detailed tutorials for all part of the buildings in all languages. You have a detailed PowerPoints which guides you through the whole, I would say, process of using this application. And lastly, we have the admin panel, where we can add new areas, add new countries, manage accounts, one maybe nice topic is that I can give you insights to other buildings, either only to view or either to edit it and so on. So it has some options like that. So now when we go more into buildings and how we basically created this tool is that you have several tabs where you input different information, such as basic informations regarding the name, of course, address, city, and so on. Some informations like a net heated area, number of floors, primary energy source for heating, and so on. I'm sorry if this is maybe too small. Then you go into the part where you can add building envelope details. What is the external wall? What is the area? Orientation? What is the thickness or the U value if you have it? And so on. Same goes for windows. You can select different windows from here. So we basically, as I said, try to simulate the energy certification process. Same goes for lighting, ventilation, technical systems. I will not now go into details. As I said, you can register and try everything to check it by yourself. On the other hand, we have two additional input tabs, warnings, where it gives you the warnings if you missed something. Here, for instance, is the error that we do not have the domestic hot water system. Sometimes it will give you the warning that maybe some value is too high or too low or something like that. So after we did this, after you inserted your building, we use the database information that we have for each region. I will show that later. And we use our methodology to calculate, maybe I will now put it here, to calculate the energy needs. So for each type of the system, we calculate energy need, delivered energy, primary energy. I'm sure that you are all familiar with this. This is the number that you actually need. So for heating, let's say, then delivered energy is what your systems delivered when you take into account the efficiency of the systems. And primary energy is something when you apply primary energy factors, it is not the same if you use coal or electricity and so on. Same goes for the CO2 emissions. Below, we have some part for the renewable energy calculations. So if you use something from the renewables in the current state, it is showed here. Here it says that this building in the current state has 2% of renewable energy. I will not go into all the formulas, we can check that later. On the other hand, apart from this, you can actually then see where you use the most of the energy, where you lose the most of the energy. For instance, here you lose it for the external windows. Some key performance indicators which are basic. And here is if you have the current PV or solar thermal system, it gives you the overview of it. This building do not have it, so it's not shown here. So that's how you create the current state. As I said, formulas are as they are. I will not now go into those. But once when you inserted this, I said that you will have the data set for the country or the region. And here you can see the informations that are in our database. So annual irradiation to calculate PV and solar thermal, value-added taxes, some prices of energy and water. As I said, primary energy factors, CO2 emission factors, set of the informations for typical buildings. That is something that we still using from the first Excel and trying to use them when you do not insert a lot of informations. And of course, investments costs, which are always very changeable, but we have defined them recently. Once when you created, I would say, your current state, then you have 11 measures to apply. So here you can see them. Basically, they are all from the Excel, as I said. So you have 4 measures for the building envelope, then mechanical ventilation, thermotechnical systems, and so on. Oh, sorry. In here, for each system, you can actually select the level of renovations that you want and the type of roof, for instance, here, as well as the price. Let's say for this one is the square meter. For space cooling, it's let's say per piece or per kilowatt, and so on. So you can go through. Maybe it would be more beneficial if I put it like this. You can go through each one of the system, select or deselect measures that you want, and later in the all you can see the total, I would say, total impact of your measures. If I deselected the lighting system in here, then this number would be 0. It would exclude this measure. And here on the first, you can see where you can save the most of the energy. Since this is the old building, without the facade, without the thermal insulation, the energy walls are the top priority. And of course, the lighting system, this building do not have a LED lighting. It has the fluorescent lighting. So it gives you the estimation. And now when you played with your measures, seeing the different values, and you selected your measures, you go into renovated state, where it compares how much of the energy you saved or you didn't save. For instance, usually public buildings do not have very good cooling systems. So when you install new cooling system, the consumptions goes up. But here in the brackets, you can see the change and the comparison with the current state. So for instance, if I apply all the measures here, I can save around 80% of energy. I can save maybe nothing for the domestic hot water, as I didn't apply. Here I can see some other measures, and below again the calculations of renewable energy. It was 2%, now it is for 53%. Again, I can go through the consumption, through the energy losses, and PV hot solar. Here there is I would need a separate webinar to explain this.
Yes, Marco, I'm so sorry.
Yeah.
We'll have like our 4 last minutes to the
Of
webinar.
course.
It's really
Of course.
interesting, though.
Yeah.
Thanks a lot for showing everything.
I have after
I'm
this
sure.
one more slide after this. So
Okay.
basically, here you can calculate these measures, and as I said, you can export it. Lastly, just to go back. Oh, sorry, I moved it. To go back on the one last slide that I have is the future work. So you saw this. This is nice to see, but to be honest, we are now including the section to upload project documentation so that you have the project designs, main design, and etc. We, of course, lack of accuracy in the calculations, so we are now expanding the inputs that we need. We are connecting our platform with the building sensors to get the 100% correct input regarding consumptions. We are completely readjusting the methodology to comply with the new norm that will come with EU standards and so on. And we will use the AI to generate various scenarios, because now when you saw, you can manually select. What we will create is that you get 10 different scenarios and can compare them simply to ease up the process. As I said, we do not have operation and maintenance costs. We do not have life cycle assessments. Now we are including that. And more or less, that's it. This is now done through another EU project called Smart Decarb. It's again the Interreg, but EPA, cross-border cooperation. But that's one very small part. What we decided to do after everything is that we will develop it with our own funds. We bought the programmer company, which is very unusual for public sector, but we incorporated the programmers in our staff, and we will try to develop it by our own funds, by staff costs, through other EU projects, through our funds to create something better. So that's in short this. So yeah.
Thanks a lot.
I don't know if there are any time for questions, but you can
yeah,
share
we don't
my
have.
email. I'm always happy to answer, to organize calls. As I said, this is EU tool, free to use. So yeah, it's
just great. Thank you so much for introducing it. I'm sure that many people will find it useful. And I'm just so sorry that our time is limited, and there is no possibility to go into much depth. But hopefully, if anyone is interested in getting to know the tool, to use it, feel free to reach out to us, to me, or to Marco. I will get you guys in touch. So thank you. And I think then let me just quickly check the chat. I don't see any questions here. So let's maybe just wrap up our session for today. If we don't have any questions coming up at the moment, and since Marco has other commitments starting already now, we will let him go. And thank you, Luigi, as well. I think you did amazing overview and introduced it in simple words, easy to understand people without engineering background like myself. So thank you, guys, and thank you for joining us today.
Thank you.
Thank you, Anastasia. Thank you, Marco.
Thank you, everyone. Have a nice day.
Thanks.
Bye.